video, what we're going to be talking about is the distribution of sample proportions. So this distribution describes the distribution of sample proportions, e.g. the proportion of successes in a series of trials. It is used in situations where we are interested in the proportion of a particular characteristic within the sample. When the sample size is large, the distribution of the sample proportion is approximately normal. And that goes in with the central limit theorem, which we talked about in the last video. So this is a Bernoulli mean histogram that I have created. And then so you can see that this is a population proportion is 0.6. The sample size is 30, and the number of samples is 1,000. So, let's see what we've got here. So we've got 1,000 rows, like 1,004 rows of data of ones and zeros. And so a 1 is going to be success, and a 0 is going to be not success. So we've got 1,000 rows of success. These are your Bernoulli trials. And then you've got 30 columns. 30 columns of 1,000 rows. And then we calculate the p-hat, the sampling distribution p-hat. So that's your mean, the average of B5 to AE5. So what you're doing is you're averaging a row. And then you copy this all the way down to cell, I believe it's 1004. So you have an average of 1,000. So you've got 1,000 samples, I believe it is. Yeah, you've got a sample size of 30 and a number of samples of 1,000. And then so you take the average of each row, and then what you do is you create a histogram. And we talked about histograms in previous videos. And basically what this histogram does is it proves the central limit theorem. And the central limit theorem is it doesn't matter what the distribution is. If you have a large enough samples and you sample it enough times, after a while the distribution of the means will resemble a normal distribution. And so this looks like a normal distribution, so that proves the central limit theorem. And the means of the trials form a normal distribution, which we've proved that. So that's your Bernoulli mean histogram. So in the next video, we're going to be talking about the chi-square distribution, and so I hope that you decide to watch it.